Guys, we'll just wait for a few more minutes, maybe around 2 or 3 minutes, then we'll start. Okay, it's now 2:16. I think we have waited enough for the rest to be able to join in. Let's start the discussion. So for today, what I've thought out about discussing to you guys is more on an application of network security. So things like how would you be able to, let's say, interconnect multiple branches and put them, in such a way that it's still safe for that environment. So they would still have this internet connectivity on top of being able to directly talk to each other. Not just by paying out a lease line or whatnot, but just basically relying on the internet connection that it's already paying for. So for this, we're going to be using the DMVPN technology. This is basically a multi GRE tunnels that just utilize this NHRP protocol, the Next Hop Resolution Protocol, on top of obviously, since our course is about network security, we're going to put IP security on top of that. So we will be able to see how this actually works by hand. I even booted up a few virtual machines that one of them is running Windows Server. The other two are using Windows 7 and just Linux operating system. So basically Ubuntu flavored. So for this topology, the system is, the virtual machine is running on a quad core processor. On top of it has a dedicated 10 gig of RAM. So if you have uh, an enough beefy system to run this, uh, I do recommend that you do this by hand, because we learn by doing practices. So if you have any questions during or even before or after the discussion, just place them in the chat window. I'm always looking at it so that we will be able to address that. So without further ado, let's start. So this is basically what we're going to be configuring. Okay. So here we have the internet connection. So this machine is actually, I'm giving it access to my real internet connection right here. So this ISP is just a router that's doing NAT translation from this private so-called IP going out. So all of our machines would be able to, let's say, open Google or do torrents or whatnot. But our objective here is that since, let's say, we have these three branches, so let's say maybe we'll put a shape to that. Okay. So this router 2 right here would signify our, let's say, main branch. Hence, it has the built-in server. And the other two would be, let's say, normal, very, very far branches. So you don't actually need to pay like lease line connections if you have a good enough internet and you're not, going to hammer that with, uh, let's say, critical applications. So let's say you just want to ensure that you would like to give access to a specific service that you're running on a specific client on the main branch itself, or let's say a database connection, or an API call, or whatnot, whatever service that may be. If you only need for that service to be accessed from the other branches, you could do so just by utilizing your basic internet. So here we have this private connections for each branch, and they will be all doing NAT for this edge routers. So these are router 2, R2, R4, and R6. And this will, from the 200 network for all of the branches, it will seem as if that's the real internet. But on our whole topology, this would be the real internet right here. Okay. So for that, we'll start by configuring the ISP first. Okay, so let me pull that terminal up. Okay, so let me just switch over to SuperPutty right here. Okay, so this right here is just an ordinary router with basically no configuration at all, as you can see. And there's no IP address or whatnot. Oh, okay, there's an IP address right here because it's set up using DHCP. This will actually allow me to, let's say, ping 1. Okay, but okay, so that works because I have this default route pre-installed right here. So that's from the testing that I was doing earlier. So what we're going to do now is we're just going to do a translation for that and assign the IP addresses. So in here, you can see that the configuration itself, it doesn't have one except for that DHCP thing right there. And for the default route that it actually got from the bridge controller. So we're going to actually put that in and specify that this is our next hop IP. So let's start. So let's say internet. We'll go inside interface Ethernet 00. We'll just say IP not outside to translate that, and put the IP addresses of the other ones. So don't forget to place IP not inside. So that's 200.0.1. This is the connection for router 2. Okay. And E02 is the connection for router 4. That's IP address 200.20. Okay. And for Ethernet 03, IP not inside, IP address 230.0.1. Okay, so after doing that, we simply need to create this default route just to make sure that it won't get like removed or whatnot. And we'll put that on the ISP side, or actually my live connection. So that's 192.168.43.1. So 192.168.43.1. Okay, so that will be the default route, and just create an access list. Say permit any, so just permits all, and create the NAT statement. So this one interface E00 overload. So this basically allows us to test for internet connection. So it's going to go down a bit. Okay, let me test if I'm able to. Okay, so my default route is incorrect because I forgot to place one right here. So what I'm going to do is remove that first and place this one. Okay, so after doing that, check again if you're able to communicate with that gateway. That's actually the IP address of one of my gateways here. Okay, so after being able to do that, we should probably be able to do this as well. So this actually have internet connection right here. Okay, so all of the known, maybe publicly known DNS servers could reach. Yeah, so it will probably lag a bit later on, depending on the signal of my internet connection. So knowing that this is all good now, we'll just save that. So there's no routing protocol right here. It's just static route. There's no routes for the specific 172 series that we'll be using on all of the private networks. And so that's going to make this as legit as possible. Okay. So first, if we were to go back to the screen or the topology, so we have configured ISP. So we'll first configure this tree. So since this is a server, I don't need to run a DHCP server here. We'll just assign it a .2 as the IP address of this Windows server right here. So that thing is actually a running live virtual copy of a Windows server. So let me show that to you. Okay, this is actually it. Okay, so earlier I just configured an IIS server for that, and on top of a static IP address. So you could see that by typing IP config and /all. Okay, so you could see that I'm using this one as its IP, the 172.16.11.2 /24 and 172.16.11.3. So I'm going to use that as the IP address of the E01 interface for router 3, and it's using all ones. So later on, when this actually is finished, I could do this and it will be successful. But for now, since router 3 doesn't have any configuration, it will be unreachable. You can't even ping router 3 because it doesn't have an address yet. So 16.11.3. Okay, so that's going to time out. All right. So going back, here's the topology again. Again, we'll start with this R3, R5, and R7. So it's going to be running under EIGRP 100 for its local routing protocol right here, so that it has connections. As for the gateways, it will just have a default route going out, and later on, after we have confirmed that it has all proper internet connections, we're going to create tunnels for that. So router 2 is going to be the hub, and 4 and 6 is going to be the spokes. So you could actually implement this on different multitude of ways. This is just like the blunt, easiest one, and at least it has IPSEC. So this Windows is actually running on Windows 7 as its operating system, and this is Ubuntu. So let me show that to you real quick. So this is the Windows 7 right here. I'm just going to log in. So just, vanilla Windows 7 Ultimate, no configuration at all. We could see, okay, so the shortcut isn't working. Say command prompt, ipconfig. So it doesn't have any configuration like here. So when cpa.cpl, so you'll be able to see that it's actually configured using DHCP. Okay, so it's going to be getting its IP address from the router 5 later on when we configure router 5. And if we were to switch to, say, Ubuntu, okay, so let me move the window there. So this is the Linux that I have placed in our topology. It's running Ubuntu. So currently it doesn't have any network connection. That's why it's telling you that. And if we type address, you can see that there's actually no IP. Okay, this is also going to be getting the IP address dynamically from the router 7 layer. Okay, so going back, the topology. So all trees are actually running their own virtual machines, their own copy of their operating system. So we'll start with configuring this one first. So going to router 3, I'm gonna switch to window now. Okay, so for this one, no configuration at all. So we'll paste the host name, we'll paste an IP address, say this is 172.16.10.3, and the subnet mask, we'll shut down, P01, paste the IP address, 172.16.11.3, subnet mask again, and then just enable that interface. Okay, right. So after that, we'll just simply enable the routing protocol. So EIGRP will place a router ID of, let's say, all trees, and will place both network addresses to be advertised and to be used for advertisement under the EIGRP process. So that's 16.11 and the /24 subnet mask, and we'll disable, obviously, summarization. So after doing that, we'll just save it, and it's good. We'll move to router 5, do almost the same thing here. So just place the host name, put the IP address on both interface. So that's 172.16.20. Let's say 5. Okay, and go to the other interface and place the IP as well, 16.21.5. All right, no shutdown. So afterwards, put the routing protocol in. So EIGRP, place a router ID. I'll just stick with 5. But you could also disable this auto summarization first. That's perfectly fine if you want that. And place the network and its wildcard mask and the other one as well. So you could, omit the wildcard mask, but what would happen is that it will, advertise using the fastful. So the 172.16.20.0 would become 172.16.0.0/16. So that's somewhat a bad idea to do. So save it. So we're done with router 5. But on top of this one, we're going to need a DHCP server here. So I'm going to set up that now. So IP DHCP exclude. Let's say I want you to not give the first 10 addresses. That would be fine. So that 1, 16, 21, that 10. So the Windows client should be getting .11. Okay. So IP DHCP full, let's say Windows clients. And we'll say the network address for that is 172.16.21.0, subnet mask, default router. This is basically its gateway. It's the IP address of this router right here. And a DNS server. Let's just put 1. Okay, so after doing that, we'll save it. And we'll go to router 7. But before we do that, we just want to make sure that this actually works. So we're going to move to the Windows machine. Okay, so let me move my screen there. All right, so this is the Windows machine right here. So if you can see, ipconfig, still not getting it. Let's say renew, release. And we're going to do the renewal. So this might take a while. We'll leave it for now. Oh, okay. So that actually works immediately. We'll say home connection, and we should be up and running. Yeah. So it got this address 21.11 because we excluded the first 10 address for that. So it's now running there. But also we could see the DNS server right here. So which basically means we could do this 172.16.21. I think the gateway was 5. Yeah, so it's now replying. And if you're wondering later why this one could be pinged, because I have set on the firewall issues that I'm allowing for both inbound and outbound rules the echo request and echo reply, both for IPv4 and for IPv6. So this is the ICMP echo request for IPv4. As you can see, it's allowed on this network, and even for the outbound connection. So going right here, ICMP out, allowed. And by default, it doesn't do that. So you have to, tinker about, fix it, like change a few configurations here and there. So going back to our console, right? So we are done with router 5, and we have confirmed that the DHCP actually worked on that line. So we're going to go with router 7. I'm going to set this up. Say R7. We'll just say 0, place the address 172.16.30. Let's just say 7. Okay. And on the other interface, IP address 172.16.31. We'll just use 7. All right. And afterwards, we'll create the exclude. This is for the DHCP itself. 31.1, we'll just exclude the first 10. This is like a best practice thing. Because you would always want not to only reserve an address for your gateway, but to reserve an address for other things that are required to have a static address. Things like network printers. Let's say, what else except for network printers? Maybe VoIP stuff, or maybe security devices. So those actually most of them needs static IP. So IP DHCP, let's say pool. Let's say for Linux clients. Okay, we'll say network 172.16.31.0, and the subnet followed by the subnet mask, followed by the default gateway. Let's say this is .7, and place a DNS. Right. So after that, before we save it, we must create the EIGRP. Okay. So router ID. Let's say this is just all 7s, and I'll disable the summarization first. That's no auto dash summary, and place the network statement. So that's 172.16.30.0 conquered mask right here. And okay, it's now warning that the meeting will end in 10 minutes. So if you get cut off, it will obviously be getting cut off. We'll just reconnect with the session, and we'll continue when this session stops. So that's 172.16.31.0. and all zeros for 5. Okay, save it. So after that, we'll just want to make sure that the Linux client is getting the DHCP for that. So we'll go to the Linux machine, stop the window right here. Okay, we'll log in. And no, the password isn't 1234. You don't want to do that. So IP ADDR, still no. Still no. Okay, might be having issues right here. Okay, it's actually off. So we'll try to connect it. Connected. Okay, we'll now check. And now we have an address. So as you can see, that is the 172.16.31.11. So that's given by the router 7 itself. We could even double check that by looking at the DHCP pool. So here in router 7, we'll say show IP DHCP, let's say bindings. So you could see that, okay, the MAC address for that Linux machine is this one. It's given now. It's now 2:36 p.m. and it's automatically given. So there's no sticky address in part. All right. So after that, we'll just save 7. We'll save 5. We'll save this router 3. So we still have 8 minutes. I think we still proceed. So going back to the topology itself, We are now done with the ISP. We have confirmed that the ISP actually has connection to the internet, and we are done with these three and these three. So the only remaining thing is to give internet connection to the three edge routers, namely router 2, router 4, and router 6, followed by, after we have confirmed that they all can access maybe Google, maybe Cisco, whatnot, service that is being actually hosted online, then we would be creating the tunnel interfaces, which would allow the connection, the virtual connection between this three interfaces right here, and to talk to each other, so that the clients which are inside would be able to talk to each other using their private IP address. And then after that, we're going to secure that using IP security. So we'll start doing that. We'll go to router 2 first. Switch the window. Okay. So in router 2, this one doesn't have configurations. Yes. Okay. No routing protocols as well. Okay, good. So we're starting from scratch. So on router 2, what we do is we, again, assign an IP address. So 210.02. Okay. No shutdown. E01. Let's say IP NAT inside. Good IP address 172.16.10.2, followed by the subnet mask. No shutdown again. And now that we have IP addresses, let's just check for its connectivity first before doing anything else. So checking if we can talk to router 3. We're good. And checking if we can talk to the ISP. Okay, so we're good. Now that we have connectivity between our neighbors intact, we'll create a default route. I'll send it out to E00 because this one is connected to the ISP. And I'll even give the IP address of that ISP so that it will be a fully specified route. So it makes life easier for the networks. Next is I want to do NAT, so I need an access list for that. Let's just say permit any, permit like everybody, and followed by the NAT statement. So IP NAT inside source list 1, okay, should be list, and forward it out of the interface E00, and always place overload, because if you don't put overload, it will just be path. So path is a single translation. It means only one specific private would be translated to a public at a specific point of time. So it cannot, you cannot share the single address, single public address throughout your whole network. So after we do this, we are going to go configure the EIGRP. So router ID, let's just say all twos. Put the net, we'll disable auto summarization first, and put the network command. So our internal network is network, right? That's 172.16.10.0, followed by the subnet mask. And we should be good. The only thing that we need to do is, okay, there's now neighbor relationship. We could even check the routing table if we got the 16.11, that is the private network that's connected to Windows Server right there. So we got that. So next is, yeah, and we can even ping the server right now. So 11.2, right? So what we're going to do next is we're going to advertise the default route from router 2 to router 3 so that the server will actually have internet, will have, gateway connections, internet connection. So redistribute static, that's good enough. And we'll go to router 3 just to double check that it actually got that update. Routing table, okay. Now we see that it's already here. So this means that hypothetically, router 3 should be able to access the internet. And right here and there. Right, so it now has internet connection. And if router 3 has internet connection, if we go to the Windows server right now, so I'm going to switch to that. Still have around 4 minutes. I'm gonna move my window, right? So this is our Windows server right here. This is the IP address. So let's ping the gateway. 16.11. That the address is 3. That's our gateway. We could now ping, say, all ones. And since we are able to reach our DNS server, we could probably do lookups. So let's say NS lookup, and let's say google.com. So what's the IP of that? What's the IP of cisco.com? And if you could do that, obviously, there's even no need to do this, but this is just for demonstration purposes. If we open a browser and we wait for a while, it's loading, okay, we can just go to google.com. So just say, yeah, don't show me this warning. And all right, so we have access to, okay, I'll just need to add that. This happens if you do this one on the server because it's not actually supposed to be used as a normal client. So that's like one of the big differences between using servers and clients. So like there's a lot of scripts. So we can even test for the internet connection right now. Hope this doesn't, lag or color or anything. And it's somewhat mediocre, only around 10 megabytes. Oh yeah, this is happening because I choked the bandwidth that is being allowed to be translated inside my virtual machine so that it doesn't actually use everything up for my internet connection. Okay, now that we have verified that this machine actually has internet, we'll move on to the next one. We only have like around 2 minutes. Maybe we'll stop the configuration around 30-second mark. So going back to PuTTY. So we'll go to router 4 and do almost the same thing, what we did with router 2. So make sure that it has the configurations, show IP protocols, just give me the summary. Okay, so we'll start and put this on the outside, paste the IP address. Okay, that 4, yeah. All right, turn that up. Go to the other interface, put it inside, paste the IP address, so 16.20, let's just say 4. All right, so after that, we'll create a default route. That's to the 220.01. Okay, don't want to do that. I want to create a fully specified default route, so it makes the routing faster, a bit faster. So no more route reverse lookup process. So after doing that, let's just make sure that it actually works before we do anything else. So good. And how about our local? Yeah. All right. So it's now less than a minute. So I'll stop for now and just wait for the video to, close, and we'll see each other again. Just reopen the session and we'll pick this up from there. Any questions? This should be like fundamentals to you guys because you're already in NetSec. Means you have finished data communications 1, 2, data communications 4, or should have finished first, rather. None so far. Oh, nandito pala kayo. Kumusta? Jacob, Tel, kumusta na? Kaya pa? So hi, we are now back. I'm going to go back to the topology itself. So as you can see, we stopped with here on router 4. I'm going to move on the configuration right there. Okay, so moving the window. So here, what we did earlier was basically place the IP address, put a default route, check for connectivity between its neighbors. So basically the ISP and router 5. And after confirming that, we are going to be placing the NAT statement. Okay, so that's creating the access list first. So access 1, permit any, and do the translation cell. So IP NAT inside, source, list 1, interface, Ethernet 00, and put an overload statement. So this one gives you internet access. So if you were to ping, so just to test that out, if you do this actually proves nothing because the source address for that ping right there is the 200 network. So only the ISP is actually doing the translation. So if you were to check show IP NAT translation right here, it doesn't do anything. But so a more legit way of testing, if you want to test your NAT connection, is by doing this one, source Ethernet 01. So you need to source the ping, the ICMPK request from a private address going to the public. So if you do this and still successful, you would be able to test that or prove that by looking at the translation here. So you see, after doing ping to, let's say, a public address, the old ones, it's going to be translated because it's using the source address of 172.16.20.4. And it's even translating the port number because we did the overload. statement. So after confirming that, we're just going to place the routing protocol. So EIGRP, router ID. So let's just say all fours. Place the network statement. So 172.16.20.0, the subnet mask. And be sure to disable the auto summarization. And obviously redistribute the static route. So after doing that, we'll save it and we'll go to router 5. All right. So someone's coming in. Okay. So in router 5, let's just make sure that we actually got the default route. So seeing that we have the default route, we can test for internet connectivity, and that's good. So even if you do the ping from router 5, there's going to be a NAT translation on router 4 because that is actually a private address. So it's this one. All right. So next is, as you can see, it's using UDP right here. So next is just to test if our Windows machine now have a internet connection. So we'll go to the Windows machine, move the share screen again. Okay, this is the Windows machine. Let's see if can I talk to Google. Okay, can I talk to the other DNS server? And since I'm able to do that, I could do ns lookup, and it's a google.com, or even let's say cisco.com, or even the LMS that you are using. I'm a ES Online that I forgot the address. I think it's .com. Yeah. So it doesn't have address because you actually need a trimestral. Yep. So this is the public address for that. So if you were to enter that on the browser, you would probably be able to see the website. So let's test that out. So 13.251.103. Okay, that's okay. I want to use that. And I want to close that. And we're not going to be installing Chrome here because I'm going to delete it afterwards. So that's 13 dot, forgot the address, 251.103. That's 251.103 dot, and that's 134. Okay, 134. And it doesn't give you the address because they're probably using a translation. But you could just use amaesonline.com. Nope. Maybe you need triple S. Okay, so it actually opens up. Okay, we'll move forward to that. Let's just use another useful website. So let's just use Google instead. It's like way better in terms of loading. Obviously, we closed it out since we have verified internet connectivity right here. Okay, but obviously we can't open the web server right here because there's no connection for it. So 11.2, that's the private address of the web server, and it's not going to do anything. Why? We have no route for that. But later on, we should have if everything goes well. So moving back to the PuTTY itself. Okay. So now that we are done with router 4, let's go with the last one, router 6. Okay, let's check if this one has an address already. So no. How about the routing protocol? Just print the summary. Still no. So it's just the host name itself. So we're going to place the IP address. So IPNAT outside. Put the public, simply public IP. All right. And go to E01. Put it inside the NAT and place the IP address. So what's 172.16.30. Let's just use 6. No shutdown. So after placing the inside and outside interfaces and putting the right IP address for that, okay, so what we're going to do is the default route. And please push it out of Ethernet 00. And the next up IP is 30.1. So after doing that, let's just, for the sake of making sure things work. So let's do a ping. Just test for the connectivity first. That's 30.7. Yeah, that's the right address. Okay. So After making sure that we are able to communicate with the neighbors and we have the default route, we'll just create the access list first, permit any, and create the NAT statement, IPNAT inside, source, list 1, interface E00, we'll just say overload, and after doing that, we'll put the routing protocol. EIGRP 100, let's say EIGRP router ID, which would be all 6, and let's disable this auto summarization and put the network statement, the private network. Okay, and we'll wait for the adjacency first. Okay, and even check if you want. You could also check if we have the 16 to 31 right here, so we're good. And we'll push out the default route. So after doing that, we'll save it. Go to router 7 and make sure that we got the default route from router 6. Okay, so after having that, we should be able to test for internet connectivity, which is okay, that's incorrect, which is good. So just to make sure, we'll go to router 6. We should be seeing translations. Show IPNAT translations. Okay, so we have this view. Next is, we'll go to the Linux machine. Okay, so I'll need to move the window. Okay, where's the Linux machine? Okay, here's the machine. We will share. Okay, plugging it in. No, it's not 1, 2, 3, 4. Okay, so we could test. Do I have internet from my Linux machine? Yes. So it also open, obviously, Google. Waiting for a minute. It's taking more than a few seconds. This is because I only allocated 2 gigs of RAM for this Ubuntu machine. So let's say google.com. All right, so now that we know that it has internet connection, we can even test the speed. And okay. Next is, what we're going to do is we're going to create a bridge of connections from let's say router 2 to router 4 to router 6. So how would that actually go? So now that we have made sure that this gateway has internet, this gateway has internet, and this gateway has internet, they should be able to talk to each other. Okay, so we'll test that out first. So share again the putty, go to router 2, and I'm going to send a ping request going to router 4's public, so that's 220.04. Okay, so that's good. And even for router 6. Okay, that's not at 4, that should be dot 6. And no, it's not 20. That should be 230.0.6. Okay, so now that we are sure that router 2 can talk to router 4 and 6, and even router 4 should be able to talk to router 6. Okay, so this ensures that we have internet connection for all of them and they are all capable of talking to each other. What we're going to do is we're going to create tunnel connections from router 2 to router 4 to router 6 so that their EIGRP networks would be propagated to each other, and that would actually allow private connections from one branch going to another branch just by using the internet connection. Okay, so let's start doing that. So we'll go inside router 2. This will be our hub network. The other ones will all be spokes. So it means router 2 will be handling all of the routing stuff. It will be our like controller. So we'll create let's say tunnel 0 to trace the IP address. Let's say 172.16.40.2, and we'll put the subnet mask still /24, and let's say IP NHRP. I would like to map a multicast dynamic for entry, and I'm going to assign a network ID for this one. Actually, we need a network ID for everyone. After that, I'm going to create my tunnel source would be my public address. So that's 200.10.0.2. Okay, and I'm going to say that this tunnel should be using GRE multipoint, not point-to-point, so that we have more connections. On top of that, since I'm going to be placing IPSEC later on, I'm going to set my MTU to not use 1500 but 1416, so that is just the right amount to squeeze in the IPSEC later. So put no shutdown right there, and we're good. Next is we're going to move to router 4. So this one is the configuration for the hub. So you could let's say tunnel 0. Okay, that's interface. Okay. Oh, it doesn't want to show the section for tunnel 0. Okay, we'll just say begin, since it doesn't want to cooperate. I think this is, yeah, should be capitalized. So we only place the IP address for the tunnel. We lowered the MTU. We set the NHRP configuration and the tunnel configuration itself. So this would allow the one tunnel to communicate with the other tunnels for as long as you have public internet connection that could reach each of their public addresses. It doesn't have to be static. Okay, only the hub needs a static address. So in router 4, we'll create another tunnel. Tunnel 0, let's say the IP address for this one is 172.16.40.4. The subnet mask for that /24, and we'll say IP NHRP. Please map what specific tunnel IP is our hub using. That's 172.16.40.2. So this is the IP address of the tunnel 0 of router 2 or our hub. And what is the public address to reach that one? That's why the hub needs a static public IP. Otherwise, you could be changing configurations from here and there every time the public address of that hub router changes. Okay, so again, this is the private IP, the tunnel IP address of the router 2, the hub, and this is the public address for me to reach this tunnel IP. I'm going to talk to this public IP. Okay, that's what's happening right there. So next one is IP NHRP. We'll say map. I want to enable multicast on that. So the 200.10.02, the public IP of the hub of router 2, the hub which is router 2, and I'm going to place a network ID for that. Okay, they should have the same network ID, and I'm even going to say my next hop server should be 172.16.40.2. So this is again the tunnel address of router 2. And followed by, okay, I'm going to create my source. So my source should be my public address. So that's 220.4. That's the public IP of router 4. And I'm going to say my mode will also be GRE multipoint. Okay, so after that, again, adjust the MTU for the IPSEC to work later on and just say no shutdown. So after doing that, we should be able to fairly, ping, say 172.16.40.2. Okay, that's pig, not ping. Okay, so even without anything else, we should be able to communicate directly with the private address that is configured under the tunnel interface of router 2. Okay, so we move on to router 6. Okay, we'll do almost the same thing. Let's say interface tunnel 0. I will say IP address 172.16.40.6, subnet mask, and followed by IP NHRP map 172.16.42 200.10.0.2. That's a private loopback, not loopback, tunnel IP of the hub, public IP of the hub, right? So after doing that, NHRP, we'll say map multicast for 200.10.0.2 and IP NHRP network ID. Okay, that's NRP. It should be NHRP network ID 1. After doing that, we'll also specify again the next hop server, which is for 172.16.40.2. And I will finish it off by typing the tunnel source. Should be 230.0. Okay, it's 230.0.6. That's the public address of router 6 right here. And we'll say the tunnel mode should be GRE multipoint. And adjust the MTU again. That's 1416. Okay, so what you have, what you should be noticing here is that, okay, in the section of tunnel 0, right? So typically, if you were to create a point-to-point tunnel interface, so you have a site-to-site configuration, so one site connected to another site statically, you would need another tunnel destination to be placed here. But since we are going to be doing DMVPN, so it's dynamic multi-point, we'll even put it even to phase 3. So we don't need to put that. So the tunnel, the devices itself would create dynamic connections to other devices. So connections from one spoke to another spoke would be happening directly. So only the first connection would be about asking the hub, well, hey, what's the public IP for this tunnel interface? And the hub would reply to that with that inquiry, and the spoke will now be able to directly communicate with the other spoke that he's trying to talk to. Okay. So what we want to do now is we want to do advertisements between the routers. So let's say from router 5, which is the sitting inside router 4, if I look at the routing table right now, I only have this default route. What I want to happen is that I want to be able to open the web server from router 3, which is sitting inside router 2, the hub, to be accessible from my Windows client and from my Linux machine. I mean directly without doing port forwarding and stuff. Just do private connections, because from here, currently we won't be able to do that. So if we want entries to be placed here, what we are going to do is advertise also that advertise that network within our EIGRP statement. So before we do that, we have to fix the tunnel first. So let's say hold time for EIGRP 100. I'll just say maybe around 5 seconds. You don't want to put this too low. Don't want to put this too high, because if too low, sudden jitters in your network, then network goes down. And if it's too high, then if it already went down, you won't even notice it. Okay, so something around, let's say 5 seconds, or let's say maybe around 35 seconds would be good enough. And let's say no IP except self for EIGRP 100, and we'll even disable the split horizon for EIGRP 100. So we need to disable this split horizon thing here because this is the hub network. So it's going to need to advertise whatever it accepts from the going inside the tunnel interface. So that router 4's advertisement going to router 2 will be forwarded to router 6 using the same tunnel interface. Okay, so it's the same thing if you did the frame relay configuration with multiple devices inside a single frame relay interface. Okay, so after doing that, we'll go inside the routing protocol. So router EIGRP 100. And we'll say, please advertise my tunnel network. So that's network 172.16.40.0, and followed by the subnet, the wildcard mask. And we're good from router 2's perspective. So if I'm going to do an adjacency for that, because if we were to check to show IP EIGRP neighbors, you see that there's only one neighbor. That's basically router 3. Okay, so if we need to have a neighbor relationship between router 2 and router 4, we'll also create the tunnel here. Okay, so interface tunnel 0, do literally the same thing. Hold out time EIGRP 135 seconds. Disable the IP next up self for EIGRP 100, and also disable the IP split horizon for EIGRP 100. So after that, just advertise the network inside the routing protocol. Okay, the computer lagged a bit. Hope it doesn't crash while we're recording. And give it a few seconds. Okay, there's now an adjacency that formed. That's a good thing. So if I look at my routing table right now, that only for EIGRP entries, I should be able to see the Windows server's network, which is 172.16.11. And there it is. So that basically means I would now be able to talk to that server. Okay, so clients for the Windows 7 machine will now be able to open that. But before we test that out, let's just finish the configuration first. So we'll go to router 6 and do the same thing. So interface tunnel 0. We'll say IP holdout timer for EAGRP 100 is around 35 seconds. It should be 35 seconds rather. Next up self for EIGRP 100. No IP split horizon, say EIGRP 100. Next is we'll advertise the network. So router EIGRP 100 again. Place the network statement 172.16.40.0 and the wildcard mask. Wait for it to go up and it's now good. So show IP EIGRP neighbors. And now we have 2 and we have tunnel 0. Okay, so after doing that, we'll just save it. So router 4 will save it again. And oh, I did not test it. So let's go inside the network of router 4, router 6, that's router 7. Let's show IP route EIGRP. Okay, now you'll be able to see this one. So let's see if I'm able to talk to the Windows server. I hope it doesn't turn off now. Okay, so that's good. So what basically means is now we have full routing connectivity between all of the branches. Okay, so just to test that out, I'm going to open the Windows 7 machine. I'm going to move to the Windows 7 machine and let's say, can I talk to the server? Yep. Can I actually open the service itself? So 172.16.11.2. And yes, so yeah, that's the one. It says hello world. Okay, so next is I'm going to move to the Ubuntu client. So move the window here. Right, log in the client. And test for connection first. Open the terminal. Send the ICMP echo request. And we're good. So if we try to open that inside the client, okay, so that's 172.16.11.2. That's the server itself. Okay, say hello world. So what's happening is we now have full routing, private routing connection from all of the branches between the spokes. So the only problem with this one is that if you were to go back here, say where's topology, okay? So if the ISP was watching, and they probably are watching, so let's say I'm going to watch the Ethernet 03. So I'm going to open Wireshark. Okay, so that works. Going to move the share window. Okay, so you see here, if we were to, let's say IP address, I would like to see, okay, it's saying end in 10 minutes. I hope we can finish this one before that ends. So this is the 31 one. No, I want to look at 11.2. Okay, so you see here, it's being logged, all of your connections. So if you are not encrypted, and currently we're not doing any encryption, so all of the things that we are sending is actually in clear text. So the ISPs could actually be watching us. That's like a really bad thing though. So just to prove that, so we'll see this entry, it will add up. I just need to move to the let's say this is what interface? Ethernet 03. So that's the Ubuntu server, Ubuntu client. Going back to the Linux client, and we'll say hit refresh, hit it again, move back to the Wireshark, and as you can see, it added entries. So as you can see, this one is like literally in clear text. If we were to follow the TCP stream right here, okay, that's not opening up. We'll just say, oh, it's actually right here. So follow TCP stream. Okay. It's not showing up anything. Wait, let me fix that. And next, and we'll pick one. So as you can see, even the EIGRP hello messages are being seen here. And there is no encryption. There's no security right here. So everything is like in clear text. Really bad idea. in doing site-to-site configuration, because everybody would be able to see everything that you're doing. See, we even caught the clients actually asking for a connection. This 112, the 200, that's actually a public address. So maybe one of my machines is trying to do an update. Hopefully they don't consume too much of a bandwidth. So this is the Firefox thing. So as you can see, everything is like literally clear text. So what we want to do is we want to like encrypt, at least protect the information that if we are trying to talk from one branch going to the other branch. So you see here, say if I wanted, what you want to do is if you're accessing, let's say, sensitive information over the main branch or over whatnot branches, you must place encryption in your tunnel interfaces or in your tunnel networks. Okay, so we're going to do that to not obviously allow the ISP to snoop in on us, because we don't want them to know what we're doing, obviously. So I'm going to stop Wireshark. Okay, so from this point, I'm going only to be adding a configuration to what we have already configured. Okay, so this is for just for the IPSEC configuration. Okay, so we'll go to the router 2. And obviously the tunnel will go down. I mean, the neighbor relationship will go down while we're doing this, but it will go up afterwards. So let's say crypto is a camp. I want a policy. Let's say 10, we'll name 10. Use hash MD5. This is not like the best way to do it, but this is just one way of doing it. This the easiest way so that it doesn't take too much of a load on my machine. So encryption, 3DES. On production environment, obviously don't use 3DES. It's like really easy to crack right there. And authentication, I would just use pre-shared key. You could also use SSL encryption if you want to do that, but since in the topology I did not create a certificate authority, the signing object, I will just use pre-shared key. So after creating a policy, I'll create crypto as a camp, let's say key, and let's make it relatively easy that you should not do this. Let's say Cisco 123. Okay, there's like a really bad way of doing this. And the address that follows it is basically telling the configuration. Okay, if you see this, if you match this address, if the transmission matches this address, then use this key. So if we use all 0, it means match every connection, everything. So we only need one key. So crypto IPSEC, I need to create a transform, and let's just name it mine. Let's use ESP triple DES because that's like the lightest one. Afterwards, I'm going to create a crypto IPSEC profile, and since we're doing DMVPN, we'll just name it DMVPN. It's okay. And set a transform set to mine because it is mine here. Okay, next is we need to apply that. So before we apply that, what I want to do is copy paste this commands to router 4 and router 6 because they need to be the same thing. So I'll check the running configuration first. Okay, so it's basically this one. Let's see if we have other entries. So that's the policy, the encryption, the hash, the pre-shared key, the actual key, the transform set. What else do we need? The profile itself. That's good. So just simply highlight, okay, and go to router 4. Right click, paste, okay, and go to router 6, and also right click, paste. So it's now we now have literally the same configuration. So after doing that, we can now enable it on the tunnel interface. So tunnel 0, to enable that, it's simply tunnel, protection, IPSEC, and my profile name is DMVPN. And I simply need to highlight that. So, okay, now it will enable that. So highlight, go to router 4, go inside the tunnel interface 0, do a right click, paste, and do the same thing for router 6. Interface tunnel 0, right click, paste. So now, the tunnels will now be enabled. It will now be protected. So, earlier we didn't have protection, so all of the things that we are transporting is in clear text. So that's really like a bad way of doing things, and it should still be working. So we'll check that. So router 7, can I still open the server? Yep. Can I still open Google? And even it's public. Okay, even the other one. Yeah. So if I go to router 5, can I still have internet connection? Yes. Can I have connection to the web server? Yes. And last thing, router 3 will just test for internet connectivity, because this one will obviously be able to talk to the web server because it's directly connected to that, because it has the network. So show IP route, EIGRP will give you, this is the private LAN for router 4's network. This is the private LAN for router 6 network. This is sitting, this is where Linux, the Linux client is sitting on. This is where the Windows client is sitting on. Okay, but the only difference here is that we now have like proper, somewhat proper protection if we want to have inter-branch connectivity. So yeah, we have like 2 minutes left. So I'll open, okay. Let's first go to the Windows machine. Okay, let's try to still open it. It still loads, we're still good. And we go to the Linux machine. So here, I'm going to switch that to here, okay? And log that in. Takes a second to load. And load this one, okay. So just to prove that this is actually the server itself, I'm going to rename that title. So, because we're already done, just for kicks. This is the web server itself. We can modify the code. The HTML code is right here. So initpub, w. This is actually it. This is the file that it's loading. So let's say hello world. We'll say yay. And save it. So close, close. If we were to move to the Linux box, so as you can see here, hello world. If we were to refresh, it says yay. And if we were to move to the Windows machine, obviously. So say, okay. So that will be it for this meeting. Hope you learned. Okay. Better take care of your tunnels if you're going to be network engineer someday or network admins. If you have any questions, you could just simply send me a message through the LMS or just send me an email. Here's my email.